At what happens to op amps when we are in AC circuits. For a quick refresher, remember that our op amps have two terminals, a positive terminal and a negative terminal, and the general behavior is that the output of this op amp is the difference between the positive and the negative terminals amplified. And in our assumptions for the ideal op amp model, we assumed that this amplification value right here was infinite. And using that sort of infinite assumption allowed us to make really nice models about how an op amp should behave and how we could create certain amplification circuits in adders and subtractors to do the operations that we wanted. However, in an AC circuit, this behavior is quite different. So if you ever dug into the LM324 datasheet, you might have seen this chart here. And what this chart is telling you is what happens to the voltage gain as a function of frequency. And so this voltage gain is our A parameter that we had before, telling us how much gain we expect out of our op amps. So our horizontal axis here is how that gain changes based upon frequency. And our horizontal axis is written in a logarithmic scale, so 10 to the 0 would be 1, 10 to the 1 is 10, this would be 100, and so on. And so what you can see is that for low frequency signals, so things sort of less than 10 hertz, our gain is constant. Our gain stays at about 110 and really doesn't change that much. But as the frequency of our incoming signal grows, as the frequency gets higher, what happens is that gain ability of our op amp begins to rapidly decrease. And the way this might show up is that, let's say that we had a signal, and let's say that it's this black signal here, and we wanted to amplify it. And if it was a low frequency signal, maybe we would get an amplification at this level right here. That's a terrible one. I'm going to redraw it. Maybe if we expected this value here, but because we're operating at a point in our circuit where our gain is not as much, maybe we don't get as much amplification as we intended. So, the blue is sort of what we predict from our ideal models about what our amplification would be, but our red is what actually happens because we're operating at a lower gain level. What's happening underneath is that our assumption of having, infinite gain is starting to fall apart, and instead of having 110 dB, well, now maybe we only have 60 dB, and so our assumptions just don't hold anymore. And this is going to become important when we deal with filters, and instead of amplifying signals, we're going to be trying to attenuate them or reduce them, and we'll use our ideal values to figure out how much a signal may be reduced, but depending on the frequency of that incoming signal, we may not get what we expect. And so this will become a design challenge for us as we deal with op amps in various frequencies, that we might have to put in more gain or more attenuation than we think to get the results that we want. And what's going on underneath is that our assumptions of having infinite amplification are really getting reduced, and we're down to real levels of amplification, and we have to deal with these non-idealities in our circuit.